Section 1.2, translating statements into mathematical expressions. Okay, so first off, I want to give you a few vocabulary that will help you to translate certain phrases into mathematical operators. And so, um, and as with any language, you really have to look at the context in which these words are placed in order to translate them correctly. And so, I'm going to just be giving you like a dictionary these words, but that doesn't necessarily mean that uh, in a different context they may give you they may mean something different. So first, addition. So I guess I'll. So this is sort of a vocabulary. So first, addition. If you see the word more than, such as 5 more than 3, you could say, well, this is 5 more than 3. Say the word more, 5 more x would be 5 more x. The sum of, so the sum of x and 3 is just x plus 3. The total of, the total of a, let's say, 8 and 4, 8 plus 4 plus 3 plus 2. Added to 7, added to 5. So 7 was added to 5. Increased by 5, increased by 2, 5 plus 2. And so these are some common words that are associated with addition, subtraction. Minus, 5 minus 3 less 4 less 2 less than 8 less than 3. Well, the then will switch the order, so it will be 3 minus 8. So notice above, actually, with the addition, there are some cases where I switch the order because of some additional modifying words. But it really didn't make any difference. 3 plus 4 is the same as 4 plus 3. But with subtraction, it does make a difference. Subtracted from, how about subtract? 8, subtract 2, 8 minus 2, subtracted from 3, subtracted from 6. Again, the from changes the order in which you subtract. Decreased by 5, decreased by 2, 5 minus 2. The difference between, so the difference between 6 and 4. 6 minus 4. So those are some common terms associated with subtraction. Multiplication. Times 3 times 4 multiply by 6 multiplied by 3. The product of the product of 4 and 5 twice. Let's say twice 4 2 times. So twice always means to multiply by 2. Triple So triple 5 means to multiply by 3. 3 times 5. Double. To double the number, let's say 4. Means to multiply by 2 of. So this is when preceded by a fraction, decimal, or percent. And so if of is preceded by a fraction, decimal, or percent, 1/2, say 1/2 of 6, it means to multiply. And so if you have a fraction, a decimal, a percent preceding the of, then the of means to multiply. Division. Divided by 8 divided by 2. 8 divided by 2. The quotient of the quotient of 12 and 3. 12 divided by 3. The ratio of the ratio of 18 and 2. 18 divided by 2 divided into say 6 divided into 3 parts. So 6 divided by 3 into sometimes 5 into 4 over 3 over 8. Okay. So these are some common words and phrases that mean multiplication, division, subtraction. Equal. The equal symbol. is 5 is 3 plus 2. R, um, well, double. Let's see if I can think of a phrase. Um, well, can't think of anything good here. Uh, 6. Okay. um, uh, Sec R was were uh, those all can mean equal depending on the situation. They're just other tenses of is. Um, Equals 3 equals 1 plus 2 gives 6 plus 1 gives 7. Okay. Should be 8 minus 2 should be 6. 8 minus 2 is equal to 6. Yields 5 plus 4 yields 9. So 5 plus 4 is equal to 9. Amounts to 8 times 2 amounts to 16. 8 times 2 equals 16. Represents 6 minus 4 6 divided by 2 represents 3. 6 divided by 2 is equal to 3. Is the same as 8 over 4 is the same as 2. 8 divided by 4 is equal to 2. How in the world did I say 8 divided by 2 is 3? 6 divided by 2 is equal to 3. Um, is equal to 4 is equal to 3 plus 1. 4 is equal to 3 plus 1. Makes 3 plus 4 makes 7. 3 plus 4 is equal to 7. Okay, so that's some words that would give you equal. Okay, so a algebraic expression consists of some constants, numbers, variables, and some operators such as addition, subtraction, multiplication, division, um, raising things to a power, and taking roots of numbers. Okay, and so things like 8x minus 7 is an example of an algebraic expression. It involves some constant 8, 7, some variable x, and it includes multiplication. I'm multiplying the 8 times the x, and subtraction. Okay, the cube root of 7 plus 4x cubed. That's also another example of a algebraic expression. Okay. An example of an equation is an expression equal to another expression. So, for example, 3x minus 12 equals 14. That's an example of an equation. We, in general, solve equations. We simplify expressions. We evaluate expressions. But we never solve expressions. And so expressions are never solved. So if I tell you to solve something, it's not going to be an expression. And if you try to solve an expression, then what you're doing is wrong. Okay. You do not evaluate equations. You solve equations. I guess you could simplify equations, but um, in general, if you're going to be solving something, it's going to be an equation. A solution. A solution to an equation are values of the variable that make the equation into a true statement, such as um, this equation has a solution of x equaling 2 because if I replaced x by 2, then I notice that 2 times 3 is equal to 6 plus 4 is indeed equal to 10. And this is a true statement. And so when I substitute into my equation um, that particular value, the variable, I have that now this equation is a true statement. So, inequalities. This symbol means less than. So 3 is less than 12. This symbol means less than or equal to. So 8 is less than or equal to 8. Now that's a true statement because it's equal to 8. So 8 is equal to 8, therefore it's less than or equal to 8. Greater than. Notice also on the number line, um, A is less than B if A is to the left of B. Greater than. 4 is greater than 2. Greater than or equal to. 4 is greater than or equal to 2 because it's greater than. Not equal. Five is not equal to 3. So 5 is not doesn't have the same value as 3. Uh, Whenever you put this dash, this little slash line, it means not. So this symbol here is not less than. Okay. So 7 is not less than 3. This is the same as greater than or equal to. So if it's not less than, then it's greater than or equal to something. Not less than or equal to. Not less than or equal to. So 9 is not less than or equal to 6. This is the same as greater than. If you're not less than or equal to something, then you're greater than something. Not greater than. So 5 is not greater than 9. This is the same as less than or equal to. 5 is less than or equal to 9. Not greater than or equal to. So 4 is not greater than or equal to 11. This is the same as less than. If you're not greater than or equal to something, then you must be less than it. Okay. Let me do on page 23. Oops. Problem number 3. A number increased by 9. In exercises 1 through 16, change the phrase into an algebraic expression. Use x to represent the unknown variable. Okay, so I want to translate a number x increased by plus 9. And so I can translate this into the following: x plus 9. Let me do problem 6. 9 times a number added to 7. So let me translate this. So 9 times a number x added to plus 7. Okay, so let's write this down. So this is 9 times x added to 7. And that is your answer. You can write it as 9x plus 7 also, but the pure translation is 7 plus 9x. Let me do problem 7. 9 added to a number, and so 9 added to a number. And so I have 9, oops, which is added to x. So x plus 9. Let me do problem number 9. The quotient of 11 and a number. And so the quotient of division 11 and a number x. And so this is just the quotient of 11 and a number. So 11 divided by x. Let me do problem number 12. The quotient of 7 times a number and the sum. Wait, I'm doing problem 12. The quotient of 7 and quotient of 7 and the sum of a number and 8. Okay, so let me do this. So I have the quotient of what? Well, 7 and the sum of a number and 8. Okay, so I have to figure out, so it's the quotient of this and of the 7 and the other stuff. So let's figure out what this other stuff is. And so this is the sum of a number and 8. And so I have the quotient of 7 and the sum of a number and 8. I can write this in a different type of notation, so I don't need a parentheses. So it's the quotient, so I'll use the division bar, of 7 and the sum of a number and 8. And so if I do that, then I don't need a parentheses. The parentheses understood when you do it as a division bar. So 7 over the quantity x plus 8. Let me do problem number 14. A number multiplied by 10 decreased by the square of the number. Okay, so let's do this. So this is a number x multiplied by multiply 10 decreased by the square of the number. Okay, so this is multiplied by 10 decreased by, so 10 here, decreased by minus the square. The square means to a power of 2, the number x. And so this is to the power of 2. Okay, so let's do this. So I have x, a number multiplied by 10 decreased by the square decreased by the square of the number. And that's your answer. Let me do an example. A number multiplied by 10 decreased by, oh, there it is. Sorry. A number multiplied by 10 decreased by the square of the number. And so this would be a number multiplied by 10. And so even though, so a number multiplied by 10 decreased by the square of that number. And that is the translation. Now, we usually actually write numbers in front of variables, so I would usually write this as follows: 10x minus x squared. let me do problem 16. The quotient of 7 added to a number and 10 decreased from the number. Okay, so let's do the quotient. So the quotient means to divide of 7 of what? Well, 7 added to a number and 10 degrees from the number. And so that means that we're going to have first this 7 added to a number, and then for the denominator, uh, for the divisor, we're going to have 10 degrees from the number. And so these are two separate phrases. So I have here 7, which is added to a number, and I have here 10 decreased from the number. So let's write this, and I'm going to write this as a division bar. So the quotient of 7, which is added to a number, and 10, which is decreased from the number. And that is your answer. So we have the quotient of 7 added to a number and 10 decreased from the number. And so the from makes it go in the opposite order. Let me do problem 19. In exercises 17 through 24, change the statement into an algebraic equation. And so now we're going to have equations. And so problem number 19, 3 raised to the fourth power is the same as 9 squared. Okay, and so let's do this. So 3 raised to some exponent, the fourth power, the power 4, is the same as, that's an equal, 9 squared. And so it's to the power of 2. And so I have here 3 raised to the fourth power is the same as 9 squared. And that is your answer. Let me do problem number 21. Seven multiplied by 6 is equal to 84 divided by 2. Okay, and so 7 multiplied by 6 is equal to 84 divided by 2. Twenty-four, 6 raised to the third power minus 4 squared is equal to the twice two equal to twice 10 squared. Okay, and so I have 6 raised to the third power minus 4 squared is equal to twice 10 squared. And that's my translation into an equation. Let me do problem 25. Three x cubed minus 57 x plus y. In exercises 25 through 32, identify the given entity as an equation or as an expression. Well, this does not have any equal sign, therefore this is a expression. Let me do problem number 26. Two x plus 7y is equal to 5. This has an equal sign, so this is an equation. Remember, you can solve equations. However, you cannot solve expressions. Problem 27. 4x squared minus 7x is equal to 8 over x plus 1. Again, this is an equation. I can solve equations. 28, 8x plus 1 over x equals 6. This is an equation. I have an equal sign. 29, 5 plus x over 3x minus 1 equals 0. Again, this is an equation. We have an equal sign. $30 1 over x plus x equals 20x squared. Again, there's an equal sign, so this is an equation. $31 x cubed plus 7x over 3x squared plus 5. Well, this is a expression. There's no equal sign. We simplify. We evaluate expressions. However, we never solve expressions. 32 2x plus 3y plus 7 minus 4z. Again, this is an expression. There's no equal sign. We never solve expressions. Let me do problem number 34. Seven x minus 2 equal 10. In exercises 33 through 43, find the solution, if any, of the equation in the set 2, 3, 5, 7, 10. So I'm only looking in this set with those 5 numbers. And so the question is, well, is the solution in any of those is in that particular set? Well, let's check. Let's check if x is equal to 2 is a solution to my given equation. So 7 times 2 minus 2 equal to 10. Well, 14 minus 2, is that equal to 10? 12 is not equal to 10. So the answer is no. Let's check. I'll even put it up here. If x equaling 3 is a solution. And so let's replace x by 3. And let's check if it's a solution. 7 times 3, 21. Minus 2, is that equal to 10? Well, 19 is not equal to 10. So no, that's not a solution. Let's check further. Let's check if x equaling 5 is a solution. Let's see, 7 times 5 minus 2, is that equal to 10? 35 minus 2, is that equal to 10? No, 33 is not equal to 10. Next, let's check if x equaling 7 is a solution. And so 7 times 10 minus 2, is that equal to 10? Is 70 minus 2 equal to 10? No, 68 is not equal to 10. Okay. And lastly, so we've checked 2, 3, 5, and 7. Let's check if x equaling 10 is a solution. And so I just did, I just checked 10, didn't I? 49, 47. Okay, so x equaling 7 is not a solution. So let's check if x equaling 10 is a solution. And so is 70 minus 2 equal to 10? No, 68 is not equal to 10. Therefore, there is no solution for the equation 7x minus 2 equaling 10 in the set 2, 3, 5, 7, 10. So no, there is no solution in this particular solution set. So in the future, we will be able to solve equations, and you'll have to keep in mind that when we're solving these equations, we're doing it over some particular solution set. Usually the solution set we're going to be looking at is the set of real numbers. So we'll usually be looking for solutions in the set of real numbers, but not always. Sometimes we'll start out with looking at solutions in the set of real numbers, but later in this course, I think in chapter uh, 9 or 10, then we'll be looking for solutions in, let's say, the complex numbers in the complex field. Other cases, we'll actually be looking for solutions uh, in just a set of integers or rational numbers. But usually we'll be looking at them in the set of real numbers. And so keep in mind that when we say solution, we also have in the back of our mind a solution in a particular solution set. And so there may be no solution in this particular case in this solution set, but maybe if we expand the idea of how big our solution set is, if we include more objects in this possible set of solutions, then maybe there is a solution. In this case, there's no solution, but there may be a solution in some other solution set. In this case, some maybe rational numbers. Okay, let me do problem number 46. The difference of 3 times a number and 10 equals 21. Okay. In exercises 44 through 58, change the word statement into an equation. Find the solution, if any, in the set of 0, 1, 2, 4, 5. Okay, so let's do that. Let's first find the equation. So this is the difference of 3 times the number and 10 equals 21. So let's check if x equals 0 is a solution. So is 3 times 0 minus 10 equal to 21? Well, 3 times 0 is 0. Minus 10 is a negative 10, so no, negative 10 is not equal to 21. Let's check if x equal 1 is the solution. And so is 3 times 1 minus 10 equal to 21? Is 3 minus 10 equal to 21? Well, 3 minus 10 is a negative 7. That's certainly not equal to 21. By the way, please note that when you're checking if a statement is true, it is necessary to put this question mark above, because if you didn't put the question mark above, you would be writing an incorrect statement. So if I said 0 minus 10 is equal to 21, well, what you've written is wrong, because as you can see below, it's not. And so it's very necessary to put in the question mark. Let's check x equaling 2. And so is 3 times 2 minus 10 equal to 21? Is 6 minus 10 21? No. Check. X equaling 4 is 3 times 4 minus 10 equal to 21? Is 12 minus 10 21? Well, no, 2 is not equal to 21. And lastly, let's check if x is equal to 5. And so, check. If x equaling 5 is a solution, 3 times 5 minus 10, is that equal to 21? Is 15 minus 10 equal to 21? Well, no. 5 is not equal to 21. And so this says that there is no solution for the equation 3x minus 10 equaling 21 in the solution set. 0, 1, 2, 4, 5. Okay. Let me do problem number 60. Five squared, 49. In exercises 59 through 60, identify the symbols equal, not equal, less than or equal to, greater than equal to, that makes the statement true. Okay, so, well, 5 squared is 25. Well, I know that 25 is less than 49. So 25 is, well, equal 49. No, that's not correct. But 25 is not equal to 49. That's a true statement. Less than, is 25 less than 49? Yes. Is 25 less than or equal to 49? Yes. Is 25 greater than 49? No. Is 25 greater than or equal to 49? No. And so these three statements are true statements for the 25 and the 49. Let's do part B. 8 squared, 2 to the 6. Well, 8 squared is 64. 2 to the 6, well, that's also 64. 2 times 2 is 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64. And so, yes, 64 is equal to 64. It's not true that they're not equal. It's not true that 64 is less than 64, but 64 is less than or equal to 64. 64 is not greater than 64, but 64 is greater than or equal to 64. And so these three statements are true. Let me do part C. 4 cubed and 2 to the 5th. 4 cubed, well, 4, 16, 64. 2 to the 5th, 2, 4, 8, 16, 32. 64 equaling 32 that's not a true statement. 64 is not equal to 32. 64 is 64 less than 32 is not correct. 64 less than or equal to 32, that's not correct. 64 is greater than 32. 64 is greater than or equal to 32. So those are the true statements. Let me do problem number 62. 13 greater than or equal to 8. In exercises 61 through 68, rewrite the statements in a different way by changing their relational symbol. Okay? And so 13 is greater than or equal to 8. That's the same as saying that 13 is greater than 8. That's also a true statement. Let me do problem number 70. Six minus 2 squared less than 13. In exercises 69 through 78, determine which statements are true and which are false. Well, let's see. 2 squared is 4. 6 minus 4 is 2. Is 2 less than 13? Yes. So therefore, this is a true statement. Let me do problem number 74. 6 squared not equal to 7 times 4 divided by 2. So let's check that. Well, 6 squared is 36. Is that not equal to 7 times 4 divided by 2? Well, by order of operations, multiplication and division have the same level of priority. But since it's a tie, I do the leftmost first. So I multiply 7 times 4 is 28 divided by 2 is 36 not equal to, well, let's see, 28 divided by 2 is 14. Is 36 not equal to 14? Yeah, they're not the same. So that, again, is a true statement. Let me do problem number 84. 26 divided by 13 equals 2. In exercises 79 through 90, translate the word statement into symbols. Okay, so let's do that. So 26 divided by 13 equals 2. So I've translated that equation. 90 3 to the 5th power plus 7 is greater than 200. Okay, so let's translate this. So this is 3 to the 5th power plus 7 is greater than 200. Let me do problem number 92. 3x minus 5. Evaluate in exercises 91 through 98. Evaluate the expression for x equal negative 2 and when x equal 9. Okay, so when x equal negative 2, I have 3 times negative 2 minus 5 is equal to negative 6 minus 5, which is a negative 11. Let's evaluate this when x is equal to 9. And so let's replace x by 9. So 3 times 9 minus 5. And please note that when you do a evaluation or substitution, please put a parentheses around the object you're substituting. It will prevent many errors if you do that. 3 times 9 is 27, minus 5 is 22. Lastly, let me do, let's say problem 104, 2x cubed plus 5y squared. In exercises 99 through 104, evaluate the expression for the indicated values of the variable. And so when x equal 2 and when y is equal to 3. And so let's evaluate this when x is 2 and when y is 3. And so 2 cubed is 8. 3 squared is 9. 2 times 8 is 16. 5 times 9 is 45. 45 plus 16 is 61. And that is your answer. And that finishes off section. Okay. Hmm. And that finishes off